Bismillah ar-Rahman ar-Rahim. The title of this course is Advanced Micro Electromechanical Systems, MEMS. And on the title page, you could see a number of microscopic images about the microfabrication and MEMS. Here you could see two meshing gears along the bug, and this is electrostatic accelerometer. And you could also see the scale bar 500 micrometer. So overall the dimension of this accelerometer is 1500 micrometer by 1000 micrometer. Here you could see the DMD, digital mirror display, micro mirrors, and the dimension of each micrometer is 16 micrometer by 16 micrometer. This is the linkage mechanism which have been produced with poly MEMS, and you could also see the legs of the same bug. This is the electrostatic stepper motor. This is the rotor and this is the stator along the human hair, and this is the scale bar. So overall the diameter of this electrostatic motor is around about 150 micrometer, meaning that the diameter is almost equal to the diameter of human hair. This is my slide for the students who are new in the mechatronics. So I am Dr. Farid Khan, a professor in UET Peshawar, and I am teaching in UET Peshawar since 1997. I did my BSc Mechanical Engineering 1997, MSc Mechanical Engineering Design 2005, PhD Micro Electromechanical Systems, that is MEMS 2011. And these are the emails by which you could approach me if there is anything. The course outline. So I have already put the course outline on the Google Classroom. You could go there, or you could see what topics that we would be covering in this course. The important thing for you guys is the mini project or report writing. The proposal would be due in the 6th week of the teaching, which the students would be doing. And the 10th week we would have the midterm, and then at the 18th week of the course we would have the exam. Reference books. These reference books would be not available in the library. Either you could search on the Google. If some soft copy of these are available, you could download these for yourself, or lecture slides are enough to learn. A lot of material is available on the Google. You could do the search, find the appropriate material and read it. So fundamentals of microfabrication, the science of miniaturization, CRC Press, and the author is Mark Madhu. The other book that I mentioned, Micro Machine Transducers, source book by McGraw-Hill, and the author is G.T.A. Kavik. Some journals which normally publish the work related to the, or research related to the MEMS, Journal of Micro Electromechanical Systems, Sensors and Actuators A and B, Journal of Micromechanics and Microengineering, Lab on a Chip, Biomedical Devices. The objectives and CLO of the course, to introduce the application of micro electromechanical systems, to learn method and techniques for the fabrication of electrical components, MEMS sensors and micro actuators, to apply gain knowledge to solve research-based practical problems. CLOs demonstrate an understanding of the fundamentals of MEMS, learn and understand cutting-edge process techniques and technologies related to MEMS fabrication, ability to design and fabricate MEMS sensors and actuators with standard IC and silicon-based processing technology. The grading criteria for the course assignment and quiz is 30%. Mini project, which is report writing. Initially, you have to do the proposal presentation. It is 10%, which would be in the 6th week of the teaching of the course. Midterm 20%, and in the midterm you have to present up-to-date presentation of your mini project or mini report writing. And you have to submit the midterm tasks of the mini project for the midterm exam. And for the final term exam, which contributes 40% of the weightage, again, the final presentation of your mini project. And the final, you have to submit the final report of your mini project. What is MEMS? MEMS, that is micro electromechanical technology, is a process technology used to create tiny integrated devices or systems that combine mechanical and electrical components. So in this technology, we fabricate sensors, actuators, and microstructures on very small scale. And normally the overall size of the device is less than 1 millimeter. The minimum feature sizes are in micrometer or in nanometer. And normally for the fabrication, we are using the standard IC technology and silicon based technology. Here you could see a silicon wafer. This is a silicon wafer on which you could see thousands of tiny MEMS devices, microfabricated devices, which have been produced on a single wafer. MEMS are fabricated using integrated circuit, that is IC technology. Batch processing techniques are used, meaning that MEMS are mass producible, batch producible. Otherwise, they would be very, very expensive. And the size can range from few micrometers to millimeters. MEMS devices have the ability to sense, actuate, and control. They could be used as a sensor, actuator, or you could also use them to control the system. MEMS is actually a multidisciplinary technology. It comprises of a number of engineering disciplines. In most general form, MEMS consist of mechanical microstructures, microactuators, microsensors, microelectronics in a single chip. All these technologies would be present and they would comprise a single device. Similarly, the microelectronic circuit for the MEMS would have a microcontroller, and in that microcontroller you would have a program, computer program. So also computer engineering is there, and also software engineering is there. You have to have a software to run these devices. So it is a completely a multidisciplinary technology which need the knowledge of a number of engineering disciplines. So scales and dimensions, in order to realize that in which scale the MEMS people are working. So human lengths are in meters, water drop 1 meter, diameter of human hair is 80 to 100 micrometer, human cell 1 micrometer. Most of the viruses are less than 1 micrometer. Human or living things DNA is 1 nanometer and the atom size is 1 angstrom. The MEMS ranges from few nanometers to 1 millimeter. This is the domain of the MEMS in which we are producing microelectromechanical system devices. The wafer size, silicon wafer, on which we are producing the MEMS devices, its size ranges from 3-inch wafer to 1 foot wafer. Thin film technology, we would be discussing this in the course. Thin film technology, the thickness ranges from 1 nanometer to 10 micrometer. Micro beams and micromembranes we are producing in the micrometer range. Integrated circuit technology, the scale is around about 1 millimeter, 1 or 2 millimeter. Integrated optical lithography. Optical lithography is the technique by which we are fabricating MEMS layer by layer. So the resolution of this technology is a few micrometers. The nanotechnology, chemistry, and molecular biology people are working in very small domain. They are working on the molecular or atomic scales. So their range of the dimensional scale ranges from few angstrom to 500 or 600 nanometer. Precision machining, by precision machining we mean precision mechanical machining, micro drilling, EDM, electric discharge machining. So its range is from 1 micrometer to few meters. So by that, this slide you would be in the position and you would see yourself that where the MEMS people are working in which scale or how small we are producing the devices. This is the also the slide about the scales and dimensions. Human hair 100 micrometer, cells 10 micrometers, infrared rays, the wavelength of infrared ray is almost 20 micrometers. Visible light wavelength 0.4 to 0.7 micrometer. UV light, ultraviolet light is in nanometers, 80 nanometer, I think it's 700 nanometers. Size of the protein, viruses are normally between 1 nanometer to 100 nanometer. Here you could see also the minimum feature size of Pentium 4 transistor. Pentium 4 transistor was developed way back in 1995-96, and the minimum feature size in that transistor was 138 nanometer. That was the advanced technology that time. Nowadays, we are working on 5 nanometer technology. So if you are working here, this is a nanotechnology, and if you are working in this range, so you are actually working in microelectromechanical systems. The history of MEMS. In 1939, in 1939, PN junction semiconductor was developed by Schwarzschild. 1948, the first transistor were developed. 1954, piezo-resistive effect in semiconductors have been shown. 1958, the first integrated circuit was introduced. 1959, A classical publication was done by R. Penman, and the title of that was "There is Plenty of Room at the Bottom." And that publication actually talked about that in the future human beings would be producing devices on micro and nano scale. So you could download the publication and you could read it. 1962, silicon integrated piezo actuators. 1965, surface micromachined field effect transistor type accelerometer have been invented. 1967, anisotropic deep silicon etching was introduced for the MEMS fabrication. 1977, silicon electrostatic accelerometer was introduced to the market by Stanford. 1979, integrated gas chromatograph was produced. 1982, silicon as a mechanical material was used by K. Peterson. 1983, integrated pressure sensor was introduced to the market by the company Honeywell. 1985, a process technology known as Lega was introduced by the Germany. 1986, silicon wafer bonding. Silicon wafer bonding was done by Shimbo. 1988, beige fabricated pressure sensors through wafer bonding is done. 1992, bulk micromachining is introduced in the microfabrication. 1993, digital mirror display. The micro mirror was actually brought to the market by the company Texas Instruments. 1994, commercial surface micromachined accelerometer was introduced in the market by the company Analog Devices. 1999, optical network switch was produced. These are some images of the devices from the past, well-known inventions. This is the first transistor. Transistor is the electrical switch. It was produced or invented way back November 17, 1947 by Walter Brattain, John Bardeen, and it got the Nobel Prize 1956. This is the first integrated circuit in germanium. So first integrated circuit was invented way back 1958, and it got the Nobel Prize in 2000. This is the first microprocessor produced by the integrated circuit technology, very large scale of integration, 1997, 1971. Some other successful MEMS products. In automotive industry, manifold air pressure sensor, airbag sensor, accelerometer with self-test, Texas Instruments digital mirror display, which is used in video projection systems, in all video projection systems. And the development cost of it is around about $1 billion. Inkjet nozzles, which are used in all the printers, HP, Canon, Lexmark printers. There we have used microfabricated nozzles. And the resolution in these printers is 1600 by 1600, meaning that there would be 1600 and 1600 micro nozzles in each printer. MEMS fabrication in the world. Most of the MEMS is produced by USA, North America, 41%, Japan 12%, Germany 10%, rest of Asia, which is China, Taiwan, South Korea 9%, Scandinavian countries 6%, France 6%, Benelux countries 5%, Switzerland 4%, UK 4%, and rest of Europe is 3%. MEMS market breakdown: process control and instrumentation in industry 16%, medical and biomedical devices 32%, IT and entertainment 8%, home appliances 1%, environment 4%, defense 5%, automobile 11%, aeronautic and aerospace we are using MEMS 7%, and telecom is 16%. This is the comparison of the MEMS market. This is the pie chart for 2004, and this is the pie chart for 2009. The total market is $12 billion in 2004, whereas it grows up to $25 billion in 2009. And you could see almost the same application areas: automobile, consumer electronics, medical and life sciences, telecom, industry and process control, aerospace, defense, homeland security. So almost the same applications in both of the time, that is 2004 and 2009. This is the MEMS forecast in US, in billions of US dollars. This is 2015, so almost 12 billions US dollar is the MEMS market in 2015. And 2016, it was around about 13-14 billion US dollar. And this is the forecast. It has been done in 2016. So 17, as you could see, that the market is growing, and these are the applications of the MEMS in the products. And we are expecting that in 2021, the market of the MEMS in the world would grow up to 20 billion US dollar. So you could see that the product of MEMS or utilization of the MEMS product is growing by leaps and bounds with time. MEMS packaging market forecast by sensor type. This is the MEMS market sensors, and these are the sensors: RF MEMS, acoustic and electronic sensors, environmental sensors, optical MEMS, and inertial sensors, that is gyroscope, accelerometer, etc. So report has been produced in 2017, and afterward 2017 is the forecast. And CAGR stands for compound annual growth rate. So this is the compound annual growth rate, represents that how the product is growing or how the market is growing for the MEMS sensor. So you could easily see that the market is growing in a rapid mode. In 2016, it was around about 2.6 billion US dollars, and we are expecting that in 2022 the market would be almost 6.5 US billion dollar. This is actually the beginning when the companies start thinking about this product, the microelectromechanical system, sensors and actuators. So these are the well-known companies. They actually start fabricating or introducing those sensors in the market. So the technology area Inertial measurements. By inertial measurements, we mean accelerometers, gyroscopes, rate sensors, etc. And these are the well-known companies. And inertial measurements market baseline was $350 to $540 millions dollars, and that was the estimate way back in 2001 or 2. Microfluidics and chemical testing processing. The well-known product is Gen chip, lab on the chip, chemical sensors, flow controllers, micro nozzles, micro valves, and these are the companies who are working in producing these devices. Optical MEMS, also known as MEMS. Under this category, we are producing displays, optical switches, adaptive optics, and these are the companies who are actually producing these devices. Pressure measurement, pressure sensors for automobile, medical, and industrial applications. And these companies actually produce and commercialize those. RF technology, we have RF switches, filters, capacitors, inductors, antennas, phase shifters, change apertures, etc. These companies are doing that. And other product, we have